Guys, back with another award-winning video installment, this time on density. Key to density is first off knowing your units. We'll be working with mass, volume, and density. Mass will always be in grams. Volume can either be in cubic centimeters or milliliters. Usually it's solids that are measured in cubic centimeters and liquids that are milliliters. Density can be grams per cubic centimeter, usually for solids, or grams per milliliters with liquids. Once you know those, you can use this formula triangle. Okay, and the way this works is whatever it is that you're solving for, you cover it. So if we're solving for density, we would cover the D in the triangle, and we see that we're left with an M over a V. Okay, well, anytime we have a number on top of another number, that means to divide. So we would type in our mass on our calculator first, hit the divide by key, hit volume, and then enter. Likewise, if we were solving for volume, we would have mass, type that in first, hit the divide by key, type in our density, hit enter, and we would find our volume. Finally, if we were looking for our mass, we'd take our density, multiply it by our volume, and we would find the mass. Okay, so solving these problems is just a matter of determining what input is what based on the units given and using the triangle to solve the problem. So first one, a loaf of bread has a volume of 2,270 cubic centimeters. All right, cubic centimeters, I know that that is going to be volume. So my volume is equal to 2,270 cubic centimeters and a mass of 454 grams. Well, grams is a measure of mass. What is the density? That's the key right there. It's asking you what the density is. So we will solve for density. That means I'll come to my formula triangle, cover up the D. I'm left with an M over a V. So in the calculator, this would be 454 grams divided by 2,270 cubic centimeters. Calculator tells us the answer is 0.2, but as we are aware, we need to pay attention to the significant figures that were used in the calculation. We had 3 significant figures in the top number and 3 significant figures in the bottom. 3 being the least amount of significant figures, we need to have 3. So the way that we make 0.2 reflect 3 significant figures is we can add zeros to the end of it and not change it. Now we just need a unit. We see that for density we have grams per cubic centimeter, and those indeed are the units that we used in the problem. So that's what we will select. And the answer to number 1 is 0.200 grams per cubic centimeter. In the second problem, it's asking what is the volume. So we know that that's what we need to solve for. We know already that in this problem we will be covering the V in the formula triangle and looking for a mass to divide by a density. So the rest of the problem was the volume of a tank that can hold 18.754 grams of methanol. Well, I see grams, so I know that that's my mass, whose density is 0.788 grams per cubic centimeter. So it tells us our density. And as we already determined, we need to know the volume, so that's what we'll solve for. That is mass divided by density. So I take my mass, write it over my density. Once again, we need to take our answer and use the correct number of significant figures. The top answer had 5 this time, and the bottom had 3. So 3 is the least number of significant figures. We need to round to 1, 2, 3 places. This 7's the third place. We look one more to the right, see it's a 9. That means to round this up. So our answer that we write down will be 23.8. Volume, remember our units for volume could either be cubic centimeters or milliliters. In this problem, cubic centimeters was the volume unit, so that's what we use. Finally, a problem that's a little trickier here. We see that a bottle has a capacity of 1.2 liters. Okay, well, liters is a measure of volume. However, the only choices we can use for volume are cubic centimeters or milliliters. That means that we have to take this 1.2 liters and determine how many milliliters are there. And I have a video on this, and we've studied this in class previously. Go back and watch that video if you need a little help. But basically, we need to go ahead and do a metric conversion from liters to milliliters. We know that liters is a base unit that has a power of 10 of 0. Milliliters, the prefix is milli, which is a 10 to the negative third power. 0 and negative 3 are 3 zeros behind the 1. We always select the smaller unit, the milliliters, to equal 1 of the larger unit. Okay, so here's our conversion factor we'll use to solve this problem. I'll start with the 1.2 liters. It's a dimensional analysis problem, and we set it up so that the liters will be able to cancel. So I put the 1 liter portion of this here, and then the 1,000 milliliters will go up top. 1.2 times 1,000 comes out to 1,200. So instead of 1.2 liters, I consider this as 1,200 milliliters. Now I can use this to solve the problem. I know that my volume is equal to 1,200 milliliters. The problem says if the density of ether is 0.74 grams per milliliter. That's a density, and it said density over here, so I can write down my density equal to 0.74 grams per milliliter. What is the mass? So that's what we're solving for, the mass. If I take a look at my formula triangle, when I cover the mass, I'm left with density times volume. So this would be and type this into the calculator. And it tells us 888. We have to pay attention to the inputs that we had. 0.74 has 2 significant figures. The number 1200 has 2 significant figures. So 888 has to be rounded to 2 significant figures. That's the first, that's the second. So instead of 888, we'll have 890. And the units that we will always have for mass will be grams.